Welcome to Chapter 2, which is all about variation. Today's section is Section 2.1, which is on direct variation. So first, let's kind of think about going to Six Flags. What happens? Well, if you're going on the Raging Bull, a couple things happen, but the first thing you do on every single ride is you go up, okay? Every single ride climbs. Well, why do you go up first? Well, you want to gain speed. You want to gain speed because the higher the roller coaster, the faster the ride, right? Right, that should make sense. Okay, so this is an example of direct variation because as one variable increases, the other variable also increases. Okay, so this is direct variation, so how things vary, how things kind of go together. So as one goes up, the other goes up. And you'll see a lot of different examples of that today. But our formula is going to be y equals k times x. And k is just going to be a number. So y equals k times x, so pretty straightforward. So if we take a look at some of our first examples, we have m varies directly as the fourth power of n. So you are going to write your equations just like you read it. So m varies directly. So I'm going to say m equals, varies gives you the letter k, which is just our constant of variation, so any number, and then the fourth power of n, so n to the fourth. Pretty straightforward. Part B, the distance d a star is from the Earth is directly proportional to the length of time it takes for the light to get there. So d varies or directly proportional, either one, equals k, the length of the time it takes to get there. So k times L. That's it. Example C, true or false? The outside temperature varies directly as the time of day. So the question you're going to ask yourself, as the time of day increases, does the temperature increase? Well, yeah, until about noon, but then the temperature goes back down, right? So that would be false because it doesn't just do one thing, it goes up and then goes down. A direct variation example in real life would maybe be the more you sleep, the higher your grades are, or the taller you are, usually the bigger your size of your foot is. So two things going up would be direct variation. How are we going to solve these? Steps are written out right there for you, but first you're going to write the general equation, then you're going to find the actual k, then you're going to write that specific equation with the k, and then we're going to solve. You can kind of think of k as like your slope. Okay, that's kind of where we're going with it. It's kind of just that constant of variation, so it's kind of a slope. So if it helps you think of that, then go ahead. So go ahead, pause this right now and read example D. Okay, now that you've read example D, hopefully you can at least do step 1, which is to write your equation. So I'm going to say the cost is directly proportional, so there's my k, as the radius of the pizza, and that's squared because it said the square of the radius. Okay, now step 2 means I need to solve my k. Well, I know that a 6-inch radius costs $7. So I can plug in 7 for my cost, and that was a 6-inch radius, so I can plug in 6 for my r. So now that I can see that 7 equals 36k, so I could divide each side by 36. So I know that k equals 7 over 36. So now I have my constant. So now I can write my specific equation, which would be c equals 7 over 36 r squared. Okay, so it's just rewriting your step from number 1 with that k value in it. And then step 4 says to solve. So the question is, what would the pizza with a 7.5-inch radius cost? So then I would simply plug in 7.5 for my r, and then plug it into my calculator, and you should get $10.94. Just remember to square the 7.5 before you multiply by your k value. Okay, so let's try another example. Let's look at example E. Go ahead, read this, and then go ahead and unpause me after you read that. Okay, so we've got step 1 is just to write your equation, and hopefully you're getting pretty good at that. So I've got time that it strikes is directly proportional to the distance. Okay, so just remember your k value in there. Now, because it didn't say square or cube or third, we just leave that d. Okay, if you want to write d to the first power, if that helps you, that's totally fine. Now, step 2, I want to solve for my k value. So I know that my time was 40 seconds when the lightning was 8 miles away. So then I can simply divide each side by 8. So I know that my k here is 5. So in step 3, to write my specific equation, I'm going to plug in 5 for my k, and then I have my d's right there, so I just have t equals 5d. So to solve my question, when it strikes 6 miles away, I just plug in 6 for d, so hopefully that would be 30 seconds. Okay, so let's try one more equation. This time it's not really a story problem. This time it's just giving it to you like straightforward. So it says w varies directly as the 5th power of z. So w varies directly, there's your equals k part and the 5th power of z. Now read the next part carefully. There's going to be a comma in there, so you want to take the first information first. W equals 96 when z equals 2. So that means I can plug in w for 96 and 2 for my z. Okay, so it happened at the same time, so I'm going to use this because it's happening at the same time to solve for my k. Please, please, please remember to carry down this 5th power. Okay, there's a 5 there, there's a 5 here. Okay, that's going to be your number one most common mistake. Remember to carry your exponent. Okay, so that's going to give me 96 equals 32k. So divide each side by 32. So k will equal 3. So I can rewrite my first equation with a 3 in for my k, and again that's 3z to the 5th, carrying down that exponent to all of these. And then question 4, it says find w when z equals 3. So plug in 3 for z. Remember to do your exponents first, and you should get 729. And that pretty much wraps us up for direct variation. So what I want you to do right now is stop, think about something that you can do now or that you know now, and something that you still have questions about, and bring those to class tomorrow.